Okay, this series of videos is intended to provide the user an understanding of the operation or the standard operating procedure for our Argon polisher, which is the RES 102 from Leica electron microscopy systems. All right, so first and foremost, we have a safety declaration. This unit utilizes high voltage power supplies to generate an argon plasma. All of that is contained within the chassis, so users should never get inside or monkey about inside the chassis. There's a risk of electrocution, and again, if you open up the chamber while you're trying to ignite argon plasma, then you may inadvertently allow an RF radiation leak out into the lab space. So please don't go inside the chassis for any reason. This tool utilizes a compressed argon gas feed. You'll see how to turn that on in a subsequent video. All compressed gases are dangerous even if they're inert. And then finally, there is a very marked pinch hazard associated with the action of the load lock, which moves your sample back and forth inside the main chamber. This is the door where you will press it down to lock it in place. And then when you release the door, you must be careful not to get your fingers pinched as it comes back up under the action of a hydraulic piston. So, high voltage, RF radiation, compressed gases, don't get your finger pinched in the load lock door. Next section is section 1 of the SOP, Preflight Check. So these steps are necessary to ensure the equipment is ready for you to utilize. In the event you do not pass some component of the pre-flight check, it doesn't mean that the tool is down or unavailable for your use. It just means that you're going to need to contact staff to help figure out what's going wrong. So the very first thing we're going to do is take a quick trip across the room and go check on the argon cylinder. So we must confirm the argon regulator primary side pressure is greater than 300 psi. And we need to confirm that the secondary side pressure is pointing roughly at this 7 psi mark. This is required to make both the imaging sputter coater and the argon polisher happy. As you can tell from the copious amount of blue tape we've put on the regulator valve, please do not adjust this pressure. All right, so now that I've confirmed that I have sufficient argon gas supply, I'm going to make sure that my RES 102 argon polisher is logged in as SRO user, and then of course it has power. On the status tab, we're going to click on vacuum and verify that the vacuum in the chamber is less than 5 E minus 5 millibar. So again, status tab, vacuum. If it's not open, just pop it here to make it open, and you can see the chamber pressure is less than 5 E minus 5 millibar. The only time when you might see a chamber pressure higher than 5 E minus 5 millibar is when someone has just completed an argon purge or when someone has just unloaded a specimen out of the chamber. And in that situation, it's okay. But if the tool's been sitting idle, especially if it's been overnight, it should always be less than 5 E minus 5 or there may be a problem with the vacuum system. Again, if you run into one of those situations, contact your friendly ARSC staff member. We're also going to verify in this same page that the motors are ready, green text. Cooling is off, high voltage is off, process is off. That just helps you remember that nobody's running a process or accidentally stayed over their time. Now we're going to verify that the sample mounting kits are in the storage drawer, which is under the argon polisher. So you'll find all of those guys here. There's several different flavors, which we'll discuss in subsequent sections. And then finally, we want to verify under the motors tab that the motors are in approximately these positions. So the load lock is 138.8, that's check, and sample tilt is at minus 135. So those two motors should be in that basic range, and it will home itself if it ever gets confused. Last part is make sure that the space where you're going to load your samples and do your work is clean and free of orphan specimens, and it looks like the last person did a good job here. The next step in our little video is we are going to talk about the equipment startup. This step of the SOP is all about conditioning the argon guns so that they are warmed up and ready to attack your specimen to clean or polish or contrast it before you actually load your precious specimen. So step 1 is we're going to find the SEM sample hardware kit from the drawer just below the argon polisher. So it's the one here marked SEM. Place this on the table, and everything that goes inside the main chamber right here needs to be protected from your disgusting human oil. So at this point, you need to make sure you're putting on gloves. We don't want to have human oils inside the chamber. It compromises the vacuum and it can contaminate your specimens. Please be careful when you're taking the gloves out of the pick bins not to grab onto the fingertips. That defeats the whole purpose of putting a glove over your hand to keep the oil off of the parts. So always handle the gloves by the cuffs. And once you get one hand covered, now just be careful not to cross-contaminate the other portion of the glove. So I'm holding the outside of the glove now to put it on rather than grubbing my fingers on the inside, which will contact my human oil. So now that I've all nitrile gloved up, I'm going to basically get in my kit a blank SEM pin stub, and I'm going to insert that into the sample holder. So this little guy is used for actually loading the holder into the chamber. This is the actual holder that rides in and out. Inside this little spot, you can see I have an SEM pin stub adapter, which allows me to put the standard pin stubs that I would typically use in an SEM. We also have some large sample mount holders, depending upon what diameter specimen you're trying to load in for working. And if you need it, there's a little rig here where you can use this to hold it steady while you're fixing your sample. The basic premise of this little loading jig and why we have to sort of instruct you and such is that you must get the top surface of your specimen, that is the specimen to be polished, up even with this top surface of this little loading jig. And this is the best way to do so. Make sure you can see the grub screw that will hold whatever sample mount you want inside the sample holder. So that little grub screw right here needs to be facing out at me when I have it loaded into my little alignment jig. I'm going to tighten this set screw from the side, and now this little guy is fixed in place, such that if I remove the grub screw or loosen the grub screw, I can slide this SEM pin stub adapter out and put in any other number of sample holders. Always making sure that the flat portion of the holder, so this is curved, there's a flat, make sure the flat is facing the grub screw so that when you tighten it back down, it can't move up and down inside the holder. All right, I'm going to load this little guy in place, and I'm going to lock it in somewhere around here so it's not buried all the way down onto the sample holder. And then I'm going to insert this little pin stub in here, and you can see there's a secondary grub screw on this little holder that will lock him in place. My goal is to make sure the top surface of that pin stub is coincident with the top surface of this alignment jig. And the simplest way to do that is to invert the entire thing on a glass slide. So now I've got a clean glass slide. The surface of my pin stub in this case, or my sample later on, is now coincident with that surface. I've tightened down both of my grub screws. And now I can remove my entire sample holder assembly, and this is at the appropriate height to be bombarded with argon. I'm now going to take my little sample insertion tool and press it down over the top surface of the holder. These small detents here on the four legs are going to clip onto the outer edge of this holder and grab it ever so carefully. You'll hear it kind of sneak into place, and it'll hold itself in position. If you get really Western with it and start shaking it around the room, it's going to fall out. But you can attach it like so, and this is what allows you to easily place it in the load lock for simple positioning. All right, so we've basically gotten to the point where we follow through step 2. We are trying to basically get our holder to clip onto this SEM loading tool, and we're going to subsequently go over and load it into the load lock section. So we're moving on to the subsequent page. We're going to press service, and then we're going to press purge to purge the chamber with argon and make sure that both of the valves are responding appropriately. Once you press this purge icon, your chamber pressure will increase and your pre-pressure may slightly decrease. We want to make sure that this pre-pressure stays somewhere between 600 and 800 millibar whenever we're calling for gas. And if it doesn't, that means you may have some kind of a problem with your argon gas delivery. This sequence takes approximately 2 minutes to complete, at which time you'll see that the chamber pressure will begin dropping again, and this icon that says purge will turn back to green. All right, depending upon how comfortable you feel and how much individual arm strength you have, you're going to come over here to the load lock, and it requires quite a bit of force to overcome the hydraulic piston. So what I usually do is put one hand on top in a fist, put the other hand on top of my fist and press down until I hear it click into place all the way at the bottom. Clunk. Then when you release, it should stay stuck down. To let it close back up, it's the same operation. Put one fist here, hand on top, press down until you hear a clunk, and when you release, you should see it rising up. And just remember, don't get your fingers stuck in the hole. If you push this down but don't hear a click and let go, you'll see it's going to come straight back up. So make sure you hear that clunk and then release. All right, down inside here, you can see the load lock assembly. This transfer arm is going to shove the sample into the main chamber, which is over here. And my goal is to get that sample holder and load it in here so that I can engage the edges of the holder, the edges of the sample holder, with these little guide wheels. There's a set of guide wheels on the top and also a set of guide wheels on the bottom. And depending upon which holder you use, you're going to end up using a certain set of guide wheels. This little hex screw right here and this specific tool is what you use to actuate the third wheel, which then puts the whole sample holder in a 3-point bind. So again, it's about a 90-degree rotation, and that's what clips it into position. So now we're going to go ahead and set the SEM holder down inside the load lock. You'll see I kind of come in at an angle, lay it over, and notice that when you've got it in proper position, it'll just stand straight up inside the load lock. It sort of just, you know, sits right there on these little lips. So now I'm going to reach in with my right hand, engage my little hex tool here, and rotate so that the third wheel, the drive wheel, comes out and grabs a hold of the specimen holder down here. Now I'm simply going to grab the top of the specimen loading tool, tilt it towards me, and lift out. And I can verify with my own little eyes that the drive wheel and the two passive wheels are engaged with the SEM sample holder. And for this particular holder and all the other holders that are big and chunky, it's always going to be the bottom set of wheels. These top wheels up here are only for the thin disc holders, like the TEM holder. And you'll learn more about that in subsequent sections. So now that I've got my sample loaded in place, we're going to look at configuring a recipe that will, again, condition the guns for first use. All right, so this is picking back up on the sample loading process. Again, I've got my two little set screws for my sample holder for the SEM sample stub ready to go. I've got my little detents here on the end of my sample holder that are going to clip onto the sample holder and pick it up for me. I'm going to come in here and load this into my load lock area. So what you can see is that there are some wheels inside here, and the wheels have to engage with the edges of the sample holder. So I'm going to load that in and show you what it looks like when the drive wheel engages with the edge of the sample holder. So I'm going to come in like so, at a slight angle, and then I'm just going to stand it up so that it freestands straight up and down in the sample load lock. So now it's sort of standing vertical inside there, and the human readable text on top tells me that I loaded it in the proper orientation. Once I reach in and engage my tool with this little hex driver, I'm going to rotate 90 degrees, and you'll see over here on the right hand side this passive wheel comes out and engages with the edge of the sample holder. Now that it's gripped in place on 3 points, I'm going to just simply tilt this sample holder towards me and lift it out of the way. And I can verify with my own little eyeballs that down here I have a drive wheel, this portion, that is engaged with the outer ring of the sample holder. That's going to spin it or rotate it when it's inside the chamber. And there's two other passive wheels down here on the bottom. Note that there's another set of passive wheels and another drive wheel that are up here. Those are for only the thin profile specimen holders like the TEM, which we'll learn more about in another section. Okay, we are continuing with our equipment startup, about to run a startup sequence. We're going to now close the door. We've verified that we've loaded our sample in here properly. So again, one hand in the center, one hand on top, press down, release. And then as soon as this door closes, you'll see that red icon up there will show that the door to the load lock chamber area is shut. And now I'm able to move my sample into the chamber. So I press sample in. This will now gray out as it moves through its operations to move it forward. And if you're interested, you can watch and see that the motors are in fact busy now and they're moving around and doing some stuff. All right, our goal is to make sure that we are configuring the appropriate process that's going to run here, and it's called warm up ion guns fast. So we're going to go to program, Now we're going to confirm the conditions that we want to utilize in order to warm up the ion guns. So we're going to select SRO user. We're going to select SEM standard as our sample holder type. We're going to select a sequence called warm up ion guns fast. And finally, we're going to select step 2 of that process and verify the following parameters. Both gun 1 and gun 2 should be on. So if it's off, it looks like this. If it's on, it looks like that. Both gun 1 and gun 2 should have a high voltage of 5 kilovolts, a gun current of 2.2 milliamperes, and a gun angle of 5 degrees. The total milling time is going to be 5 minutes on each gun. And whenever the system is, whenever you verified all of these things, you're going to run this process on this arbitrary SEM pin stub just to make sure that the Argon guns start up properly and don't do any kind of unrequested damage or milling of your precious specimen. So you can verify that all of these parameters are correct. You can make sure that you see your sample loaded inside the chamber. So here you can see some of the rough surface of the SEM sample holder. If you want to look at it a little bit more zoomed out, you can select your screen here, magnifying glass, and zoom the rest of the way out. Now I can kind of see the circular nature of that SEM sample stub, and you can focus it to some extent for yourself as well. But when you're ready to start that warm-up process, just press the start button down here, and you will see a live video feed every 30 seconds or so where it's rotating the specimen for you, and you'll see the conditions of the guns, their angle, their accelerating voltage, and their current start to turn on and do their stuff here. And once you've gotten to an appropriate high voltage and you actually have current in the form of ionized argon smashing into your specimen, you'll see some kind of a colored stick here. It'll be red or yellow or green depending upon how close the gun is to meeting its set point that you've given it in its parameters. So monitor this, and in the meantime you can start getting your actual factual sample ready to load into the chamber once this warm-up sequence has completed. Again, while you're waiting for your warm-up ion gun sequence to finish, you can see right now they've got green indicators because the high voltage and gun current are very, very near the specifications I gave them. And so right now it's just sort of ticking off the amount of time it needs to go through its stabilization process. You can start thinking about how you're going to actually adhere your specimen to the sample shuttle that's going to carry it into the chamber. There's several different options. So with this hot plate, you're able to cure various kinds of liquidy adhesives like M-Bond 610 or Microstick. These guys will release, albeit relatively slowly, but under the action of acetone. So that's how you would ultimately remove your specimen from the plate if you needed to. If you're going to be doing an SEM sample, you're probably going to be working with an SEM pin stub of a certain diameter. So for that, you can just use our pre-made carbon tabs. You're also welcome to use copper tape. And if you have something that's a little bit more complex, like you're gluing together some kind of a lamella, these little metal jigs here can be used to apply pressure on either side of two surfaces you're gluing together to maybe make some kind of a cross-section sample. And because they're metal, you can just set them directly on the hot plate. Same's true for these little guys. If you have a sample you're trying to adhere for some reason onto this guy, you can just set the whole thing on here and let it cook. Most of the time you don't need to exceed about 135 degrees centigrade, and curing times are typically anywhere from 15 minutes to 1 hour. So however you adhere your specimen to the sample holder, or for TM samples a grid, just make sure that you're not using an excessive amount of adhesive that would say coat or flow over the top surface of your specimen or any other regions of interest. And in general, just be careful when you're using a hot plate and make sure it's turned off whenever you're done. In the subsequent videos as part of this series, we'll show you some specific examples of how to mount specimens, and it's incredibly important to verify that they're secure, because oftentimes the argon polisher will invert your specimen in the chamber, and if you do not properly secure it, then your chamber meets a fiery death at the bottom of the chamber, and we have to open it up and pump it back down. All right, our sample sequence is almost finished, so as soon as it hits the 5-minute countdown timer, you'll see that it drops the high voltage, draws back on the gun current, and then he was just a few seconds behind his buddy, but now I've got this lovely little pop-up that tells me, hey, you've won a prize, press to continue, and I can now move my sample out. That is my pin stub that I used for the purposes of just making my guns nice and warmed up and ready to rock. I'm going to go ahead and move him out, so you'll see it fly out of the sample chamber under the action of the load lock motors. And once this icon turns back to normal, that is, it's not grayed out anymore, I can then open the door. Please don't get too eager and open this black load lock port cover before this icon has finished what it's doing, or the system will freak out and freeze all the motors because it doesn't want to give you a pinch. And then once that sample is back into the main chamber, into the load lock chamber, again, this will gray out. So now I can open the load lock door. There it is. It came back to me just like I knew it would. I'm going to reach in with my little hex driver tool, and now I'm going to release. Actually, before I do that, I'm going to attach my sample loading tool. If I don't, it'll fall to the bottom of the load lock, and then I'm just going to be embarrassed. So I'm going to attach my sample unloading tool to the sample holder. I'm then going to rotate to disengage the drive wheel. And again, I will carefully lift the sample out of the load lock, and that's exactly what happens sometimes, so it's good that you got to see that on video. I have not contaminated the surface of my gloves, so I'm just going to reach in and fish him right out of there. If you had a precious specimen, try not to grub your fingers all over the top. Now I'm going to go ahead and load a brand new specimen on here that's an actual factual specimen I need to run for the purposes of science. Now that my warm-up is done, I'm ready to move on to something that is more controlled. Alright, so now that I've opened my load lock, after this warm-up sequence is completed, I place my sample holder, so sample removal tool, back over the sample holder, kind of click it into place. I'm going to put my hex driver in here and release the drive wheel. Now I'm going to carefully lift my specimen out of the load lock, and uh-oh, what happened? My sample holder kind of bumped the side and it came off. And that's okay, as long as you're still wearing your gloves and you haven't contaminated the surface with human oil, you can just reach in here and fish it right out. Just try not to drop it down in there. And there we go, I just retrieved it. Okay, so this pin stub is now fantastically clean from having been argon polished, and the point again was to warm up the ion guns in preparation for doing an actual factual specimen, which I'll show you the process for in just a second. So while you're waiting for your sample's warm-up sequence to finish, you can start thinking about how to actually adhere your actual factual specimen to whatever holder it's going to need to ride into the argon polisher and come back out. Over here in the laminar flow hood area, we have a couple things that you may want to be aware of. So simple adhesive options, for instance, when you're going onto an SEM stub of varying sizes, is we have carbon sticky tabs. So those are already pre-cut, ready to size, easy to use. You can also use copper tape, that's fine. If you're going to be submitting your sample or exposing your sample to a significant amount of argon milling or argon polishing or contrasting time, it may be beneficial for you to adhere it using some kind of a liquid adhesive. Two examples here are Microstick and M-Bond 610. This is by far the stronger. It's a true epoxy, a two-part epoxy. Microstick behaves very much like super glue. So both of these adhesives will remove in acetone, but it takes a significant amount of time, and they both require some mild amount of temperature in order to fully cure. So that's why you can use the hot plate over here. If you have a sample like a lamella that you're trying to compress together, these little C-clamps with a foot on them can be used to compress specimens together. Or again, if you want to glue something onto an SEM stub, you can just place that directly on the hot plate. Anytime you're using a hot plate, please make sure that it's always off before you leave, and just be careful not to make contact with the top surface. You don't want to fry your fingers or melt your gloves onto that top surface. So lots of different adhesive options here. Sometimes you'll need to make sure that your specimens, especially when you're working with TEM specimens attached to a grid, you want to give them sufficient time to cure before you load them into the vacuum environment of the argon polisher. So that can take anywhere from 15 minutes to 1 hour. So just make sure you plan accordingly. All right, now that my warm-up sequence is completed, I'm going to remove the sacrificial SEM stub and load an actual factual specimen into the SEM sample holder. So I'm going to remove this little grub screw, or loosen it, and then take this guy, put him back in his home. I'm going to seat this fresh AL stub here and take a piece of carbon sticky tape we use for typical SEM sample prep and adhere it to the top surface. Once I apply pressure, I then just have to peel the backing off the top surface here. And this goes in the trash, not in your pocket, not on the floor, not in a drawer, not on the surface of the countertop you're working on. Make sure you throw all your trash away. All right. Now I'm going to load up one of these small specimens here. These are small chips. I believe this is some kind of a memory chip. And I'm going to run this through a specific polishing sequence or contrasting sequence to smooth off the top surface. Depending upon your region of interest, once you load your sample onto the adhesive surface, it's going to, it's sort of going to receive it. Make sure that you apply pressure in at least a couple of spots. I usually try to work towards the edges to sort of tack it down. You don't want to smash your entire finger over the whole surface because that'll contaminate everything, and you don't want to scratch across the surface in too many spots. But if you pick one position, maybe at the four corners, just make sure your sample is properly tacked down, because again, this thing will invert when it goes into the chamber for argon polishing. All right, same thing we did last time. I've got to make sure that this sample surface is coincident with this top edge of my loading jig, and I'm fairly close right now, but I've got to get it a little bit of the rest of the way there. So I'm going to lock the sample holder in place. I'm going to get myself a clean glass slide, and I'm going to invert it so that my sample kind of falls down and touches that top surface. So now I'm going to tighten my grub screw, and then the entire sample assembly comes out like so, and now my sample is ready for polishing. So just like we did before, I'm going to use these little detents here on the end of my SEM sample holder to grip the sample holder assembly and translate it over to the load lock. Hex driver to engage the drive wheel. Pull back and lift out on the sample insertion tool. And now I can close the load lock. Okay, so this is a live run on an actual factual SEM specimen. You can see that I've loaded it in here into the load lock. He's locked in place with his little guide wheels. And so I'm going to go ahead and close the load lock. And then once this is finished and I see my little red door icon turn to green, I can move my sample into the chamber, and we should see a visual here of the sample once it makes it inside the chamber. I'm going to go through a process here of cleaning this sample surface because it may be a little dirty as received, and I don't want to look at a bunch of carbon schmutz and particles all over the place. I want to look at a clean surface on my specimen. So I'm going to again go into SRO user, that's my username. The sample holder that I'm utilizing is an SEM standard. I'm not going to run a sequence at this time. A sequence is just a series of steps that run back to back. And so now, with no sequence selected, I'm going to come down and select my SEM surface clean, 3 kV, 15 degree, 5 minute. In general, the steeper the angle, so 20 degree, 25 degree, 30 degree, the more aggressive your surface cleaning is going to get. And the higher the accelerating voltage, the more aggressive your cleaning is going to get. What we suggest is that you work with one of these three, 2 kV, 3 kV, or 6 kV, all at a fixed angle of 15 degrees, and just modify your time to be slightly longer if you need more aggressive cleaning. But one of these recipes is a good stock starting place for you to work from. So again, I'm going to select 3 kV, 15 degree, 5 minutes, and just like we did before we did the warm-up, I'm going to come down here into my parameter menu and verify that everything is as I thought it was supposed to be. So in this case, Both guns are on. 3 kV is the accelerating voltage. The gun current is 1.5 milliamps for both. The gun angle and the calculated milling angle are 15 degrees. That means the sample is not rotated at a different angle. And again, if I needed to change my milling time, I could grab that here by clicking on the screen and then use the big arrow buttons to make it more time or less time as I see fit. And if there are mistakes made, that's what the reset button is for. If you have things that you actually do want to sort of change, you can hit apply, and that will make those changes manifest for you. So now that the sample's in, I've got my conditions set. I'm going to hit start, and it will begin the process of rotating my sample, which I can see, kind of coming into and out of focus here. And as the guns ramp up and do their process, it will knock off the top layer of material from my sample. It will sputter it or ablate it off the surface, almost as though I were using a sandblaster or a bead blaster to remove whatever's on that top surface. And the outcome of this sort of cleaning process is highly sample dependent. So if you have any additional questions about which kind of cleaning process is right for me, please contact SRO staff and we'll be happy to advise you. The other kinds of processes that you'll typically run on an SEM specimen, in addition to cleaning, are contrasting, where you're trying to differentiate grains and grain boundaries, or polishing, where you're trying to render what is a rough surface to be much smoother by knocking off some of the surface asperities. And all of those things require a slightly different combination of accelerating voltages, currents, and sample milling angles, in addition to time, to get the desired results. Okay, I have finished my 3 kV, 15 degree, 5-minute cleaning process, so the system says I've won a prize. I'm going to go ahead and press continue and move the sample out. So again, once this icon up here turns back into an ungrayed out version of itself, then I can open the load block door and not before. Once that happens, I'll be able to retrieve my specimen, and then we'll go ahead and get everything unloaded. And you can also just double check in your status tab whenever the motors or vacuum are busy. That's generally when you're not allowed to open this or stick your fingers inside the chamber. So notice they just went back to green. These guys are both happy now, so I'm ready to open my chamber. Same thing as before, I insert my sample loading tool. I'm going to loosen using my hex driver. And now I can retrieve my specimen. Careful not to drop it. And then hopefully what you can see is that there's a very clear difference now between the sample surface that I have now, the cleaned sample surface, and the starting sample surface. There's sort of an obvious color difference now, but I've essentially cleaned several microns of material off the top of this surface, and then I will be able to see a little bit better what's going on once I load it up for electron microscopy. All right, so I'm going to remove my sample from my sample holder and place all of the SEM sample holder associated components back into this bin, and they will go back into this drawer, which is just adjacent to the Argon polisher. And after that, we have a few other things to close out our system, log off of FOM, all of the needful things that we always do as good citizens of the SRO. And subsequent videos will show you some other kinds of sample holders and other kinds of sample techniques, in addition to just the SEM capability we covered in this video.